few things. That's looking healthy. Let's hop over here. We'll start here. Let's do it like this. All right. Let me just open up what I need to open up. So let me see. No. Oh, there's another one. Every time I go to make an announcement, a student comes in. So I was like, oh, let me go ahead and give them credit. This is. Oh, come on. There it is. Cool beans. Looking good. So yeah, I'm gonna be a little bit honest. I was like, if you could see me, if I had my video enabled, I'm holding my thumb and my index finger like a centimeter apart. I was this close from canceling class. And then I looked at the clock and I was like, no, I can make it. So I like sped across town. I had like 15 minutes to spare. I was like, well, I was like, I've set everything up in that amount of time. I usually give myself like at least 30 minutes to set everything up. But I was able to do it. So I even got myself a little bit of a lunch before getting here. So I was like, okay, let's do it. I was like, I've been doing pretty good too. Like, you know, we've been meeting pretty consistently. I was like, I felt some way if I wasn't gonna be here. So let me see. So yeah, feel free. I do monitor the chat. Let me move this to the bottom. I do monitor the chat. So feel free to either type in the chat or unmute yourself if you have questions, comments, or concerns. You know, all I really ask on any given day is that you just, if you're already in the Zoom, you've gotten your attendance credit. That's all I really need you to do. You're not obligated to stay, but I do, again, if you're already in the Zoom, you've already done what I need you to do. What was it? Yeah, so I'm just gonna kind of continue where we left off from yesterday. Let me let the student in. This student, okay, looking good. All right. So yeah, again, if you have questions or anything, either feel free to type it in the chat or unmute yourself. But otherwise, I'm just going to continue where I left off from last time. So let's show that, and picking up where we left off last time. So last time, I think we did like the first 10 together. I think I was able to successfully stream that one. So, you know, so I don't know if you can see the title or not. I'm going to let you kind of discover that, and we're going to kind of keep it moving. This is due this Sunday, and you know, we're taking some time now to walk through it. So hopefully you can take advantage of it. Everybody should have the same exam with different numbers. I'm just doing it just because, you know, I know that people kind of be slow on the uptake, so hopefully you can use this to your advantage. Okay, rewrite the given equation in slope-intercept form and then graph the line, right? So slope-intercept form basically is like the y equals mx plus b. So this one we just solve for y. If we subtract the 8x and add 9, then we're going to get y equals negative 8x plus 9. Okay, so if I'm walking through them, then all you would have to do, oh, shiesty, then we need to graph. Now we got all of them correct last time, so I am going to try to go through this as quickly as I can because we can't see our score until we submit the exam, right? So I'm just practicing. I was like, okay, well, let's see how we can do it. Again, we were successful yesterday. We got 10 questions done yesterday with no errors. So we're just going to see what we're able to do today. So this is a line, right? The highest exponent on any variable is a 1. So the y-intercept is going to be 9, and it has a slope of negative 1. So I'm going to choose my line tool. The y-intercept was 9, so I'm going to go up to 9, and that's going to be my first point. And then the slope of negative 8 says to go down 8, and then right 1, and there's our second point. And that should be the graph of the line. Right, save. And that's all we can do right now. Again, we're going as quickly as we can. And again, we did the first 10 last class. So, you know, that it should be, everything should be there. Another announcement I want to give for you all. So I've updated like our Blackboard. You should see a few more like folders and content on Blackboard. I added like a copy of like the notes, like as you watch my lectures and you see handwritten notes, those should be in Blackboard now. Any handwritten notes that we've done together are going to be in Blackboard. I think I added a link to like my YouTube page and some other stuff. So just kind of, you should be seeing our Blackboard because that's our main point of contact for everything. So it should be, it's not 100% up to date, but it's more up to date than it was before, right? So anyway, that's there. I just wanted to bring that to your attention. Find the equation of a line passing through these points. Use the equation to determine whether these 3 points are collinear. Okay. I totally did not read. I like improvised because I already knew what they were going to say, and it actually matched. Okay, I'm just excited because it's Friday. Okay, even though it's overcast here and like gloomy, but just can feel some good energy. So let's see. Let's go paper. I'm gonna take some notes here before we hop over. So I'm gonna say, let's do it like this. Oh, and so another thing. So anything that you see me writing, going forward, I'll make a PDF copy of whatever you see me writing. I'll make it available before I leave the stream. That's my goal. Like right as I'm closing out, I push the PDF, and you can access it in Blackboard. So this is week 4. Week 4. Okay, this is exam 1. Right, this is what's due. So if you were here last class, you could have walked through the first 10 with us. I mean, you still can. It's there. It's just a matter of being aware. I figured I felt like folks might be sleeping, so I was like, okay, well, let me just do this since I think they might be asleep. So let me see. And I think we still got an audience. Oh, they didn't even stay. Folks are sleeping. This is why I do this. When I see everybody sleep, I'll just be like, okay, well, whoever is paying attention can take advantage of it. Okay. So we have this 4,7, and we have this 6,9. We want to find the equation through those 2 points. Then we have a third point, -2,1, and we want to see if it's collinear. I'm going to say collinear. I'll put a question mark. Okay, let's hop over to the tablet. All right. Oh, also, so we can use this time in class. We don't have to go through these questions specifically. If you're working on some homework and you wanted to get my opinion on it, you can ask me during class. We can go through any question in the homework. You know, I'm just doing these because it's kind of, I got tired of trying to encourage students to speak up. So I just like, okay, I'll just work problem sets until someone says something. Okay, so first we're going to find the equation of the line through the first 2 points. So I usually when I have a set of ordered pair, I like to do the following. I'll go x1, y1, x2, y2, right? So then we might find the slope, which is the rise over run, which is change in y over change in x. So that's going to be y2 minus y1 over x2 minus x1, and that's our slope, right? So then if we do our substitutions, I'm going to let that stay for right now, minus this. So first I'm going to replace each variable with a blank set of parentheses, and then I'm going to plug the corresponding numbers into the blank parentheses. So y2 is 9, y1 is 7, x2 is 6, and x1 is 4, okay? So then if we crunch these numbers, it's going to be what? 2 over 2, which is 1, so the slope is 1. Okay, so I'm a fan of the slope-intercept. Y equals mx plus b. All right, we have our slope. I'm going to choose, oh, you know what? Did I do that right? Yeah, I think we're okay. I don't know, I'm just going to choose the first one. I mean the second point, the 6 and the 9. So when y is 9, the slope is 1, our x is 6, the only thing we don't know is b. Right? So then b equals 9 minus 6, which is going to be 3 in this case. Right? So we got our slope, we got our y-intercept, so then our function should be y equals 1 times x plus 3. Okay, so that should be the equation of the line through the first 2 points. So now we just want to see if this equation satisfies all 3 points, okay? So I'm going to put this in a box. Style, like this, okay. So for instance, when x is 4, 4 plus 3 is 7. When x is 6, 6 plus 3 is 9. When x is -2, -2 plus 3 is 1. They all check out, all right? Work. There we go. Okay. So then I'm going to hop back over to Pearson and submit my results. Slope-intercept form, so that's going to be y equals x plus 3. Okay, maybe I click somewhere, x plus 3. And are the 3 points on the same line? I'm going to say yes, because they all satisfy that equation. Okay. And again, we can't see our score until we submit it. So I'm trying to get through because we might make a mistake for whatever reasons. So then we want to try to get to the bottom of, you know, what did we do wrong? Was it keystroke or did we miss a concept? It says the equations of 2 lines are given. Determine if the lines are parallel, perpendicular, or neither, right? Parallel, perpendicular, or neither is always, it's a simple discussion. It's basically saying compare their slopes. If the slopes are the same, we say they're parallel. If the slopes are, you can say, if the product of the slopes equals -1, which is the same as saying the slopes are negative reciprocals of each other, then we say that the lines are perpendicular. And if neither of those two cases are, if neither of those two cases are true, then we say it's neither, right? So basically, we need to find the slope of each line. So that last one, I don't even know what question that was. I guess that was number 12. I'm gonna write 12. That one. Oops. So this is number 13. Okay. I'm gonna say parallel, perpendicular, or neither. And I'm gonna put question mark. Then we have this -8x minus 2y equals -4. And we have this 3x minus 12y equals 7. Okay. Let's hop over to the tablet. And so basically, again, parallel, perpendicular, or neither is basically asking us to compare our slopes, right? So with this one, I would just solve for y. So from the first one, if we add the 2y and add 4, we'll get 2y equals -8x plus 4, okay? Divide both sides by 2, y equals -4x plus 2, okay? So the slope of the first line is going to be -4. Then the second one, if we solve for y, add the 12y and subtract 7, we'll get 12y equals 3x minus 7. If we divide both sides by 12, y equals 3 over 12 becomes 1 over 4, x minus 7 over 12. Okay. So our second slope is going to be 1 over 4. Okay. So if it's the case that the first slope times the second equals -1, then we said that the lines are perpendicular, right? Yeah, I know. I still got to do mine. Yeah, I just had to know. Yeah, yep. Okay, cool beans, because that will help out a lot. Because I'm like, yo, that's a lot of work for like no reason. Okay. Okay, so let's look at slope 1 times slope 2, which is going to be -4 times +1/4, and indeed the result is -1. So then we would say that these lines are perpendicular. That's my symbol for perpendicular. Okay, so let's hop back over to Pearson. Also, all the stuff that you see me writing, I'll make it available in Pearson. I should be able to push the PDF right at the end of class today. Okay, so we're going to hop back to, and it's going to be in a box folder. So it's easy for me to share through box. Okay. So we got perpendicular. All right, we're going to go with that. Okay, let's go on to the next one. I'm watching the clock. I wanted to try to leave some time for us to like process. We'll do the best we can up until maybe no later than 5:40. I don't want to work on any question past 5:40. And then we'll submit it and kind of see how do we do. Determine whether the following equation defines y as a function of x. Yeah, if we were to solve for y, we would get y equals -x plus 11. That's just the equation of a diagonal line. So then, yes, it's y is a function of x. That graph would pass the vertical line test, so we're just going to say yes here. Determine whether the equation defines y as a function of x. Okay, so if we solve for y here, if we subtract x squared, we would have y squared equals 81 minus x squared. To get that y by itself, we would have to take square root. And when we take the square root, that's going to introduce a plus or minus. That plus or minus causes it to not be a function. So does this define y as a function of x? I'm going to say no. Okay, moving and cruising. So if we solve for y here, we subtract the x to the 5th. Now when we take the 5th root to get that y by itself, when you do an odd root, you don't need the plus or minus. So because of that, we can say yes. But if we did an even root, like square root, 4th root, 6th root, anything like that, then it would be a no. It's very subtle. It's very subtle. And it's not obvious. Okay, so the domain. So this has two restrictions on it, right? the first thing you should be able to see is that it's a rational function. In general, the domain of a rational function is going to be all reals except any x that makes the denominator 0. So any x that makes the denominator 0, we got to throw it out. The second restriction is we have this square root. So we can't take the square root of a negative. Normally, the radicand, the thing inside the square root, will be greater than or equal to 0. But because it's in the denominator, it can't be equal to 0. So that means this radicand has to be strictly greater than 0. So then if you solve that, you'll get x is strictly greater than -2. Right? So again, what we did, we set the radicand, this x plus 2, has to be strictly greater than 0. And then ultimately, we get x is greater than -2. So the far left would be -2. The far right would be infinity. Infinity always gets parentheses. And because -2 will give us a 0 at the denominator, we do not want to include -2. So that means it also gets a parentheses. Okay? I know that was a little fast. I figured because it's a recording, you can change the speed and pause and rewind and take your time. Okay. You have to kind of take charge of your time and like be conscious of it and be savvy with it. Use the graph to determine the domain and range of the function. Okay, the domain. Domain is the very left to the very right. So the far left, that looks like what? -2? 2, 4, 6, 8, right? So the far left is -2 and the far right is positive infinity. So the far left is -2, the far right is positive infinity. Infinity always gets parentheses. In this case, -2, we actually reach it, so it gets a square bracket. The range is the very bottom to the very top. How far down does the graph go? The arrow means continue the pattern forever in that direction. So it goes down to -infinity, but the top looks like it's -2. It comes up to -2. So the very bottom was -infinity. The very top was -2. Infinity always gets parentheses for this context, and -2 is going to be a square bracket because we actually do reach the -2. Okay, I'm going to the next one. Okay, so when x is -1, the corresponding y value, let's see, when x is -1, y is 1, right? So when x is -1, y is 1. We just looked at the chart there. We're moving kind of quick. I don't know. I mean, I guess if we finish, I'll probably let you guys go. I know. In minutes. That sounds about right. Yeah, anyway. It's 2 ways. Anyway, I'm totally being distracted. Okay. Students stuff envelopes for extra money. Their initial cost to obtain the information for the job was $90. Each envelope costs 5 cents and they get paid 6 cents per envelope. Man, that sounds like slave labor. Anyway, let x represent the number of envelopes stuffed. Express the cost function as a function of x. Express the cost as a function of x. Express the revenue as a function of x. And then determine analytically the value for which the revenue equals the cost. Okay. So it says that they paid $90 to do the job, and then it also costs 5 cents per envelope. So then the cost is going to be the 5 cents for each envelope plus the $90 startup. And then how much money do they generate? They generate 6 cents for each envelope, so for each x. So let's see, the revenue equals the cost. If we solve this, if we set r equal to c, let me see. I'm going to multiply both sides by 100. So then we would get 6x equals 5x minus 9,000. Subtract the 5x from both sides. X equals, I think it's 9,000. So basically, if you set r equal to c and solve, you should get 9,000. Right? So what that means is that they have to stuff, and let me see. They have to stuff 9,000 envelopes for it to break even. So then anything above 9,000 is profit. But they don't turn a profit until they stuff 9,000 envelopes. Okay. All right. Let's see how we're gonna do. Okay, now even, odd, or neither. Let me write this one out. So this is question 21. So again, you could submit this right now up until this Sunday for full credit. Past this Sunday, there's a 10% late penalty. So it's like, I mean, you could still really take advantage of that. Like, even if you did submit it late, like, you know, if you really wanted an A minus on any assignment, I mean, you could get it. You just got to get a perfect score. But... Okay, so even, odd, or neither. This is question number 21. And you know, like, you would think that like everybody would just like make sure and blow it out of the water, but students don't. That's the only reason I keep doing it, because students don't like take advantage of it. So I was like, okay. Determine algebraically, so I'm going to say even, odd, or neither. And like some do, but not enough do to make me like not want to do it. So because so few people take advantage of like my structure, I was like, okay. Like, you know, that means they don't really want it. Like, I know if I was in this, like any kind of little anything I could get my hands on when I was a student, I just did it. I didn't even think about it. I just like, well, let me just do it, and I'll work out the rest of that later. Like, because I knew it was money. I knew it was money. So I was like, hey, look, either I do this or I'm going to be out of some serious money. Like fast, right? Okay, so let's hop over to the tablet and see what we got going on. So we want to know if this is even, odd, or neither, right? So remember from before, let me do this. Even is the same as y-axis symmetry. Y-axis symmetry. That's enough. Odd is the same as origin symmetry. Okay. And neither is neither of those. There's none of them. Okay. So then to determine if a function is even, odd, or neither, what we do, we replace each x with negative x and simplify. So first I'm going to replace each x with a blank set of parentheses. Now on bottom we're going to have 8x squared minus 6. On top we're going to have negative 4x cubed, right? And then again, we're going to, into each blank parentheses, we're going to place negative x, negative x, negative x. That's how you test to see if a function is even, odd, or neither. Okay. So on top, if we have an odd number of negatives, it's going to be negative. So then a negative times negative 4 is ultimately going to be positive. So that's going to be a positive 4x to the 3 on top. On bottom, we're going to have positive 8x squared minus 6. So then, is this the original? No. Sorry, I'm totally distracted. Come on. How? There it is. So now, notice that this is not the original. Let me see. Can we factor out a negative? Yeah, looks like we can. I'm thinking about doing that right now. Because if I try to factor out a negative from top, it would have to be negative 4x, right? So we can't really get back to the original here. So this is not the original, nor can we get to negative of the original. So this is an example of neither. This one would be neither. Okay. The definition of a function, let me put this up here. A function being even means if we do f of negative x, we get back the original. A function being odd means if we do f of negative x, we get back negative f of x, right? So the left is even, the right is odd. Right, but we couldn't get either of those going in this case. Let's see the time. Okay, we're doing pretty good on time. So I'm gonna say neither there. Okay. Let's hop back. Let's go like this. And then let's just go this way. So this should be neither. Let me see. We got like 4 more. Let's see. We should be able to finish these from today. The graph of a function is given to the right. Use the graph to find each of the following. The domain and range, right? So the domain is the very left to the very right. This looks like an exponential function. So the far left is negative infinity and the far right is positive infinity. So infinity always gets parentheses. We're going to go from negative infinity to positive infinity, okay, and beyond. What's the range? The range is going to be the very bottom to the very top. So for an exponential function, they have a horizontal asymptote on the x-axis. So the very bottom is 0 and the very top is positive infinity, right? So the very bottom is 0, the very top is infinity. Infinity always gets parentheses, and because of that asymptote, we actually we get really, really, really close to 0, but we don't actually reach it without some manipulation, right? So the range is going to be 0 to infinity like this. X and Y intercepts. X-intercept. So an exponential function has no x-intercepts, and the y-intercept in this case is going to be 0, 1. So it doesn't cross the x-axis, but the y-intercept is going to be the ordered pair 0, 1. Okay. Increasing. Okay, it's just going to be increasing over the entire domain. The function is never decreasing, and it's increasing the entire domain, so all rails. So from negative infinity up to infinity. Let me make sure I put my negative in the one before. Okay, looks okay. Constant is never constant. It never flattens out all the way. No, there's no solution. Okay. Is it even, odd, or neither? Even would mean y-axis symmetry. There is no y-axis symmetry. Odd would mean origin symmetry. So this is an example of neither. Okay, let me see. I don't know that we're going to get out of here early, but it looks like we're at least going to be able to get through the exam. So we have a piecewise function where we're going to have the absolute value of x when x is between negative 2 and 1, and then the square root of x when x is greater than or equal to 1. So it should be a v around the origin, and then the top half of a sideways parabola. It should be either b and c are the only two that look proper, but then at what happens when x is 1? When x is 1, we're going to use this line, and it's going to be itself, so it should be filled in. So I will go b there. Because when x is 1, we're going to use line 2. The square root of 1 is itself, so that hole needs to be filled in because it's defined. The domain. Okay, so the very left is negative 3 and the right is positive infinity. Maybe negative 2 and positive infinity. So it should be this one. And then the range is the very bottom to the very top, so 0 to infinity. This one. Okay. All right, I'll do this one. So in calculus, something like this. Anyway, we don't have that. I don't want to get into all that right now. Let's see. This is question number 24. Let me see. Find and simplify the difference quotient of the form. Okay, we got f of x minus f of a over x minus a, as long as x is not equal to a. Okay, we also have this f of x equals 5x squared plus x, where a is equal to 2. Okay, let's hop over to the tablet. Okay. So they gave us that a was equal to 2, so let's go ahead and find f of 2. I'm gonna write it like this. F of a, which is going to be f of 2, so that's going to be 5 times x squared plus x, with the x in this case minus 2. Okay. That's going to be 5 times 4 is 20 plus 2, which is 22. Okay. So then f of x, we're going to say it's going to be 5x squared plus x minus 22 over x minus 2. Okay. Now, maybe we can factor the thing on top, right? We want to see, can we factor into something of the form, let me see, something like this, x minus 2. We got x and x. It should be a plus and a minus. I'm anticipating it to be a 2, right? Actually, no, I need to back up. Because that leading coefficient is not a 1, right? What I'm going to do, I'm going to go through all the factors. So 5 times 22, what is that? 110? So we're going to go through the factors of 110 and stop at the line that adds up. I think it's 11 and 10 now that I think about it. Positive 11 and negative 10. They multiply to give us a 110 and add to give us 1. Okay. So what I'm going to do is rewrite this x using those two numbers. That green x in the center that you see now. There we go. There we go. My computer was totally about to die on me. I just was like going on battery power this whole time. I was like, oh wait, let's give it some juice. But we're going to rewrite that green x using those two numbers that we just found. Okay. And actually, I'm going to use the box method. I think that one's a little bit more simple. So the box technique for factoring the trinomial, the upper left-hand corner is going to be the 5x squared. The lower right is going to be the negative 22. And then the other diagonal, we're going to use we're going to rewrite this green x here using the two numbers we just found. So we're going to say plus 11x and then minus 10x. Okay? So if we look at the two on top, what do they have in common? They both have what? X. What do the two on bottom have in common? The 2, negative 2? So they both have negative 2. What do the two on the left have? 5x. So we can factor out a 5x. And what do the two on the right have? They both have 11. We can factor out a positive 11, right? So in our claim is that that numerator factors into 5x plus 11 times x minus 2, right? And the hint was, I was kind of anticipating the x minus 2, right? You saw me write it earlier, but I didn't want to like guess and check, so I wanted to take you on that journey on how to factor that, right? Okay. So then from here, now these guys cancel. I guess it'll be the same. That's fine. $5x plus 11. Okay. Okay, let me see. Let's hop back over to Pearson and submit this. We're just about, let me see the time. That is accurate. So we'll give it about another 5 minutes or so. And I kind of do want to view an example, but I'm going to go with this. I think we did it like this before. So I'm just going to go with it for now. I think we got one more. We're going to see how we did. The table shows a recent state income tax schedule for a filing return. Write a piecewise function, right? So if their income is between 0 and 15,000, then it's 3.5% of taxable income. Between 15 and 30 is this, and between greater than 30 is this, right? So if it's between 0 and 15, tax due is going to be 3.5% of their taxable income. So that's going to be 0.035 times x. Now we're going to have to do a little bit of algebra for this next one. It's going to be 0.056 times their taxable income. So whatever their income is minus the 15,000, because you want whatever's over the 15,000 plus that base fare of 525. Okay. So you want to find out whatever's over 15,000. You multiply. You take 5.5% of that plus the 525, right? And then for the 30 point, let's do a 0.067 in excess over 30. So we're going to say whatever their income is minus 30, 1, 2, 3, plus the 1365. Okay. Then we need to simplify these. So, like for instance, in the second line, if I distribute that 5.6%, it just kind of attaches to the x, and then 15,000. Let me see. Hey Siri, what's 0.056 times 15,000?
0.056 times 15,000 is 840.
Okay, so that's going to be a negative 840. And then, hey Siri, what's 525 minus 840?
525 minus 840 is negative 315.
Okay, so hopefully you were able to keep track of what we did there. We just did the algebra. Like I'm doing the algebra on the screen and kind of in my head. Like, would probably be better if we wrote it out so we can see, hey, we need to distribute this 6.7%. You get a number here, then you need to add that number to here, right? Okay. Let's see. Negative. Hey Siri, what's 0.067 times 30,000?
0.067 times 30,000 is 2010.
Hey Siri, what's 1365 minus 2010?
1,365 minus 2010 is negative 645.
Okay. So then we can just get rid of all of this. That should be it. I'm gonna go with that. Okay. Determine the graph. Okay. Let's zoom out so we can see a little bit better. So it's a piecewise function. Let me see, 15,000. So no, it could be that one. It should not be A because it's not aligning. The change isn't aligning with the 15,000. So I'm gonna strike A. It could be B, C, or D. What about 30? So I'm gonna strike B because the second change is not aligning with the 30. It's going off the chart. So I'm going to strike A and B. So I'm going to say it should be either C or D. Okay. And then, for instance, say our income was 30,000. That means we're going to use line 2. We would need to crush that number. Okay, I'm trying to find something simple. Oh, it should start at 0, right? Because if you don't have any income, you shouldn't be taxed. You shouldn't pay any taxes. Like say your income is 0, you should start at 0, right? This one starts not at 0. So even though you don't have income, let me see. Yeah, if you don't have income, you should be paying taxes. So I'm gonna go C because of where it starts. I'm just gonna go with C. Because if we plug in 0 here into that first equation, that first line, it's gonna collapse to 0. Right? Okay. Find the taxable, if you got 36,336. So that's gonna be, we gotta use the third line. That's gonna be over the 30,000, 36,336. So then 33,336. Hey Siri, what's 33,336 times 0.067 minus 645?
33,336 times 0.067 minus 645 is 1,580.512.
512, so 0.51. Okay, nearest cent, right? Okay, we're gonna go with this. Tax due 1500. I think that's about right. I'm not gonna worry about that. Okay, let's see how do we do. So we're pretty much stopped at about the time we wanted to stop. We're gonna cross our fingers, okay? See how do we do. Submit the test because we gotta go. We definitely made some mistakes. Okay, let's go back and see. Let's see what's going on. So 21. Odd. I thought so. Negative of the original. Oh, that was negative of the original. Yeah. And I looked at it. I paused, just moving too fast. That definitely is odd because we could have. Yeah, negative times the negative. I got tripped up by the double negative. That was totally. I saw that and I just didn't like think about it. Yeah, we definitely got that one wrong. Oh no! I didn't want to close it. No, shyster. Oh well. I can't. I think I can pull it back up. Let me try to pull it back up. Let's go back here. Trying to move too fast. Let me sign in. Come on. Let's see. I want to see my score here. No, I just want to see my results. I don't want to start it. I think if I go to the grade book, hopefully, I don't think you guys can see this. So. I just want to review it. Okay, let me share the screen. So let me go back here. Let me just make sure it's sharing properly. I don't think that's the right one. Yeah, this one, right? Okay, we're gonna share that. And let's go ahead and make that full screen. And then we're gonna do a new share. Not only that one, but also this share. Okay. All right. So I think everybody can see it now. So the distance between, oh no, that's one that we skipped. So I think we got to the bottom of 21, what we did wrong there. Let's go back to 22. Well, let's see, that's correct, that's correct. Did we miss something? We probably, yeah, I think we just didn't see it there. It was too small or whatever. We just didn't see it. Oh, no, what? You know what? I think we put 0, 1. Tag on it. It's the notation. We put 0, 1, and I keep forgetting this thing just wants just the number itself. That's fine. So we didn't miss anything there. Just the wrong formatting. And I'm sure we did that again. Like I think there was another one that asked for something like that, and I definitely put an order up here. Okay, let's look at this one. We got that number wrong. 17. Let's see. We got, you know what? I think I did 33 and it was supposed to be 36. 36, 333. Let me try the 36, 333. Okay. Hey Siri, what's 36,003? I can't get it. 333.
36,003
Thank you.
is an integer. 36,003 is also odd and is not prime.
Let me see. Let's try this again. Hey Siri, what's 36,336 times 0.067 minus 645?
What's that?
I don't think she heard me. I'm gonna have to do it again.
Working on that.
I'm gonna have to try it again. Yeah, I think last time I said 33,000 instead of 36,000.
Please try again.
I'm gonna try one more time. Hey Siri, what's 36,336 times 0.067 minus 645? Okay.
36,336
Yeah.
6 times 0.067 minus 645 is 1,789.512.
Yep, I definitely said the wrong input. Just trying to move too fast. Excited because it's Friday, but you know, we get it. It's okay. So then, like, if I were the student, what I'd have to do is decide, okay, do I want to keep that score? And like, again, you can go back because I know that some of the errors could come from like formatting and stuff like that. So that's why I give you multiple attempts and I try to give you a chance at it. Let me suppress this really quickly. I'm gonna just go like this. I'm gonna share. I want to send this to Box. That's fine. Okay, so I'm loading a copy. I'm loading a copy of anything that you saw me writing, and it will be available. Okay. I don't think there are any burning questions. Let me go here. I want to go here. Actually, yeah, that's fine. And on that note, we're going to end the session here. And from one beautiful mind to another, are there any questions? I think we're okay. Okay. So we're going to end the session here, and from one beautiful mind to another. Let me see. I'm eager to like end out the class. So we did successfully at least get through the entire exam between yesterday and today. So, and the recordings should be there, right? I guess I can bring this back up. And I think I loaded the PDFs so that you all can use them for reference. So you can use them. I mean, I don't know if people actually listen to these or actually use my notes, but you know, you are welcome to use it if it's available. Let's see. Let's go like this. But it's okay. Kick it on. But yeah, otherwise, come on. Let's go on this. Yeah, otherwise I can't really think of any major announcements. Again, this exam is due this Sunday, and I'm available if you guys have any questions. On that note, we're going to end the session here, and from one beautiful mind to another, enjoy the rest of your day. Peace.